Hello, welcome back. In this lesson, we're going to look at trigonometric identities, and there are three questions I have here, question 1, 2, 3, and each of these are a specific trigonometric identity that we have to work through. So let's do one question at a time. Let's get into it. Question 1. So which of the following is equivalent to 1 minus cos of 2x? So this is a double angle identity, and there are four equivalent expressions of cos of double angle. Three of them are involving the sine and cosine. One of them involves tangent only. But for this specific question, because our choices are all sine and cosine and sine, the very first one that we're going to use, or the first of the expressions, is this one, is the cos²x minus sin²x. This expression is equivalent to cos of double angle, cos of 2x. So that's what we're going to use. We're going to basically put that into that expression, 1 minus cos of 2x, and then solve. 1 minus cos of 2x becomes 1 minus, open bracket, cos²x minus sin²x. All right, now here is the trick to this one. When you have 1, there is another very famous, the fundamental identity that we will use, and that is the Pythagorean identity, and that says sin²x plus cos²x, that is equal to 1. That's called the Pythagorean identity. Okay, so we're going to replace this 1 with with sin²x plus cos²x, and then minus, now we're going to do the math in this one. I'm going to multiply that through, minus cos²x plus sin²x. And now we're going to collect like terms and then simplify. Well, we have sin²x and sin²x there. So we have 1 in here, 1 in there. So we have 2 sin²x. Then what we have, I want to change the color so you can see, we have cos²x minus cos²x. That's actually 0 when you subtract. So basically this 2 sin²x will end up being your final answer. And then you match that to question 1, and you notice that D is the correct answer. All right, let's go through question number 2. So question number 2 says sine to the fourth of theta minus cos to the exponent of 4 theta. So this is not a square, this is not cubic, this is it's basically a quartic. But having said that, is an expression, identity, sine and cosine. Let's go through that. The first thing you have to do, you have to realize that this is actually a difference of squares. So let's try to figure out what the difference of a square is. Now, remember the difference of squares. I'm just going to remind you, a squared minus b squared, that's the difference of squares, because a squared is a square, perfect square, and so is b squared. So when you factor that, that becomes a minus b and then a plus b. And that's how you factor the difference of squares. But here what we have sine to the fourth theta minus cos to the fourth theta. So in this case, what we will do, sine to the fourth theta minus cos to the fourth theta, that's equal to, and in this case, what we are going to do is we're going to break it up. We're going to say this is sine squared theta minus cos squared theta, close the bracket, and then open again, and then becomes sine squared theta, this time plus cos squared theta, close the bracket. That's the difference of squares. Remember, sine to the fourth of theta is a perfect square term. And so as this, the cos to the fourth of theta. So we can do this. This is the difference of squares. We expanded it, we factored that. Now, we just talked about the first, when we went through the first example, we dealt with Pythagorean identity, sine squared theta plus cos squared theta. In this case, theta is x, actually, same thing, but doesn't matter, different notation. And also, we went to the cos double angle identity, okay? So we're going to use probably one or both of these. So we know that sine squared theta plus cos squared theta, Pythagorean identity, this value right here that we have in here, right there, that bracket is 1. Okay, that's Pythagorean identity. And now we're going to rewrite. Okay, now let's go rewrite squared theta minus cos squared theta. And then this 1, you can multiply that by 1 right there, but that's not going to change anything. All right, now if you go through some of the trigonometric identity, you realize that there is no such a relation for sine squared theta minus cos squared theta. But there is a relation for cos squared theta minus sine squared theta, as we talked about in the first question. And this was the cos of double angle. Okay, so in this case, what we will do, we're going to basically rewrite this in a smart way. So we will factor the negative 1 out of, when we factor negative out of sine squared theta, that becomes minus sine squared theta. And then factor negative out of negative cos squared theta, that becomes positive cos squared theta. And now we're going to go rewrite this, okay? When we rewrite that, we get negative, open bracket, cos squared theta minus sine squared theta. And this, we already know, that's the cos of double angle. That's a cos of 2 theta. So the final answer here, it will become minus cos of 2 theta. Minus cos of 2 theta. And that's how you go through question number 2. And then you've matched the answer. That would be, for the choices that we have, answer will be B. Let me change that to the red. B is the answer, minus cos of 2 theta. All right, so that's good for now. And in another video, I will deal with question number 3. I hope you enjoyed this video. Come back for more examples and lessons in math. Be well.